Okay, this is the function generator. It's about 1 kHz signal, 45 millivolt peak to peak here. The input for the microphone. Okay, this is the SOMMERKAMP TS-340. It's similar to the ROYCE 1639 here, 40 channel AM SSB. The problem is I have very low power on LSB and poor power on USB. We can see here on AM, this here is a 1000 Hz signal here, tone signal from the generator. I will send here. Power is about 3.567 watts here on AM, and on LSB, switch on LSB here, it's about 5 watts, 4.6 watts here, and on USB, poor, very poor, 30 milliwatts here. You can see the power meter, poor power here on USB. Okay, I think it's about the problem with the crystal filter. I think that frequency shifted here, and we will look what's the problem. Okay, I must desolder the old filter here, and here. Okay. That's going out the filter. 1 and 2. This is the old filter, the replaced filter, and I want to make measurements here about the frequency offset. Okay, the frequency is 9.785 MHz. The power about 24 millivolts, the signal here, and these are the two probes. Output to the signal, input to the scope here. And this is the signal, 5, 10, 15, 20, about 25 millivolts here. And now the signal, drive to filter, input, output, and we can see on the scope. Frequency is 9.785, and you can see the signal is going down, out. Okay, the USB beat oscillator frequency is about 9.7825 MHz. Okay, frequency is 9.7825 on USB. Drop the filter, and we have no signal. And the LSB beat frequency, oscillator frequency about 9.7875 MHz. Okay, we are on the LSB frequency 9.7875. Drop the filter here, and you can see the signal is about 15 millivolts here. Yes, a little bit signal here, but you can see the frequency here, 9.791. It's not the right frequency. I think the filter is out of order. Okay, I'm back here with a new filter, a new old filter here. It's also a 9.785 filter. from a similar radio is from a Globe phone GS480 DX. It's a clone here of the SOMMERKAMP TS-340 or ROYCE 1639 here. And we will look here at the signal trough, the two probes here. We can see the signal here, very strong here, no attenuation. Okay, 9.785 here. The filter is in the circuit here, and I will look the signal strength here is a very good, no attenuation, and a very fine scope signal here. Okay, I will look here on single sideband frequencies. Okay, here we are on 9.7825 MHz for USB beat frequency, oscillator frequency here. Trough the filter here, and we will look on the scope. And that's fine, no signal here, that's a Roger here. The carrier must suppress it. And now we go look to the LSB frequency. Okay, now we are on 9.7875 MHz, the LSB frequency for BFO here. Here the filter, and we will look on the scope. Yes, no signal, and that's right here, the carrier must suppress it. And we are back on 9.785 here, the filter and the scope. Very good signal, very fine signal here with a filter, with a new filter. And now this filter must go into the SOMMERKAMP TS-340. Okay, the filter is in, and I must tighten the nuts and screws here, nuts and screws. Okay, I resolve the filter input point and the filter output point. Okay, the filter is resoldered. I will look the power here on the test equipment again here. Okay, we are on 27.405. The level about 50 microvolts into 50 ohm, and we have exactly S9 here, S9 on AM, on USB here, also S9, and LSB also S9, but I must realign the receiver section here, and now I will look the power of SSB first in AM. Okay, yes, about 3.6 watts on AM, and on USB audio 15 watts here, yes. On LSB audio also 15 watts. I think the transceiver is now repaired. Okay, now is to realign the receiver and the transmitter section here, and I think it's a very good radio. I'm very happy now. Thank you for the visit. Good luck.